Assalamualaikum and good day everyone. So today we are going to continue with the last lecture of this topic, which is still in subtopic 6.3 and 6.4, which is measure of the central tendency and measure of dispersion. But for this lecture, the learning outcome, we are going to focus on find and interpret the mean, median, mode for group data. Okay, so now we are going into the group data and then explain the symmetriness and skewness of the data. It will be the same as the ungrouped data lah. And find, interpret the range, variance and standard deviation for group data, and find and interpret coefficient of variation for comparison of two data distribution. Okay, basically everything we learn in this lecture is the same as for ungrouped data, but we are going to focus into group data only. Okay, measure of central tendency of frequency distribution. So basically, we are going to focus on the same three things for the central tendency, which is mean. What it means is the average. So it will be in case of frequency distribution x1, x2, x3 and so on has corresponding frequency. And this implies x1 occurred f1 times, x2 occurred f2 times and so on. Okay, hence in this case the mean is equal to summation of fx divided by summation of f. Okay, but now this x, because x we for the group data we have the interval for the group because we don't have any specific value of x. Okay, so what is this x? Okay, now for the median. A cumulative frequency curve or GIF is used to find the median of group data. As defined earlier, the median is the middle value, which implies 50% of the value are less than or equal to the median or more than or equal to the median. Okay, thus the estimating the median for group frequency distribution is 1 over 2n is used rather than 1 over 2n plus 1. Okay, the median is given by x bar equal to Lm. What x bar, sorry, else x curl equal to lower boundary of the median class and then plus with the n over 2. What is n over 2? The total frequency divided by 2. So half lah. And then minus the cumulative frequency of the group before the median class, and then the frequency divided by the frequency of median class multiplied by the class width. Okay, cumulative frequency of classes before the median class. Okay, and mode x cap. So to estimate the mode, we should determine the model class. Okay, so for the ungrouped data, we directly know that the most frequent will be the answer lah. But because we have the class in interval form, we need to find the exact value. So usually in high school, we use the histogram to find the mode, right? But now we didn't use the histogram. We don't have to write to sketch the histogram. We use this formula to find the mode. First of all, we have to determine the model class. What is model class? Model class is the class interval that has the highest frequency. And then the formula escape is equal to the lower boundary of the model class plus with d1 over d1 plus d2 multiplied by c. So what is d1 and d2? So d1 is equal to the difference between frequency of the model class and the class before. But d2 is the different frequency of the model class and the class after. Okay, so C is the class width. Okay, so all this is the formula. So continue with the measure of dispersion. Okay, variance and standard deviation for group data. So actually the formula is the same as the variance and standard deviation for the ungrouped data for the frequency distribution. Why? Because we have f and x, the frequency and x. But for the group data, this x is the middle point or the midpoint. Okay, this is what we need to differentiate between ungrouped and group data. Okay, the midpoint of the interval. Okay, how to find the midpoint? We just have to find the average lah. Okay, so find the average between the lower and upper boundary. Okay, let's see how do we find all of this for the group data. Okay, lastly, coefficient of variation. So the formula is the same. It's always the same. CV is equal to standard deviation divided by mean multiplied by 100%. Okay, so let's see some example for the group data. Okay, so you can see the difference with the group data and the ungrouped data of frequency distribution. So for group data, we have the class interval. Okay, we have in the form of interval. Difference with the ungrouped data, we only have specific value for each of the data. Okay, but now we have interval. It's just a summarization. We don't have the raw data here. Okay, let's say the height to the nearest of 50 to the nearest cm of 50 students are summarized in the table below. So the height between 155 to 159, we have 4 students. And then 160 to 164 is 5 students. So we continue up to the group 180 to 184 is equal to 5 students. So calculate the mean, median, mode. So we have to apply all of this formula lah. Okay, for mean. Okay, first of all, for the group data, what we need to do is to find the midpoint. The x will be the midpoint lah. X, which is the midpoint. Okay, so we will multiply the value of x midpoint with the frequency. Okay, now after we multiply, we will have the total. We add up all this value lah after we multiply the value. Okay, and then for median, we need to know the median class. So how to find the median class? It's the 50%, the 50% point. So what is the 50% point? We need to find the cumulative. Okay, cumulative frequency. So we need to find the cumulative. After that, we can determine which one is the model class. Okay, so let's see how do we solve this type of question. Okay, calculate the mean, median, and mode. So what we need to do first of all is to find the midpoint. Okay, so the midpoint is x. So how to find the midpoint? We can use the interval here. How to find? We can directly use the, it's either the, if we have the lower and upper limit, we just have to use lower and upper limit. If not, then we can use the boundary. It's depend on the type of question. So here, we need to find x, so the midpoint. And then we need to find the multiplication between fx. So we have f, we have x, so what is the multiplication? Okay, so, and then lastly, we need to find the cumulative for the median. Okay, now we need to find the x. So we just have to add up 155 with 159 and then divide by 2. So it will be 157. And we continue with the next value. It will be 162, 167, 172, 177, 182. Just add up the lower and upper boundary and then divide by 2. And then to find the fx, so usually we use it manually. Okay, but by using calculator, you can directly skip all of this value to get the summation of fx, which is equal to 8480. Okay, if not, then you have to find it manually. Just multiply each of this value f and x. It's corresponding x lah. Okay, and then total up. So this is summation of fx. Okay, and then we need to find the cumulative. So 4, we add up with the previous cumulative, we don't have. Okay, so directly it's equal to 4. And then the next one, the next class 5, we add up with the previous cumulative distribution, which is 4 equal to 9. And then 18, we add up the cumulative previously, we get 27. And then 39, and then 45, and then lastly is 50. So we have all the data we need already. Okay, later in tutorial, I will show you how to find by using calculator. Okay, if we have discussed the tutorial for the ungrouped data, so I will show you also. So you know already how to find the summation of fx directly by using calculator. So if in examination, oh no, we don't have exam for this topic. So we can, for the assignment, we can just skip this part. Directly, you just put this line in this part. what we need to do is to find what is summation of fx. But we need to put the value of x in the table. X and the cumulative. For this part, we can just ignore and just put the summation of fx is equal to what? Okay, so now to find the mean, we just need the summation of fx, which is here we have 8480, and then divide with the total frequency, which is equal to 50. So we get the answer 169.6. So this is the mean. Okay, and then how about the median? So the mean is equal to 169.6 cm lah. The mean of the height of the student. Okay, to find the median. Okay, now we have the formula for the median, right? Which is equal to the lower boundary of the median class plus with n over 2 minus cumulative of m minus 1 divided by frequency of m and then multiply by c. So, to determine the median class, what we need to do? We have to look at the frequency, cumulative frequency here. So, we know we have a total frequency 50. So, the middle point should be the 50 over 2 observation, right? So 50 over 2, half of the observation is 50 over 2, which is equal to 25th observation. So where is this 25th observation lies? Okay, di mana dia berada? Di dalam group mana? Okay, so we know that cumulative means that the first to fourth observation will be in the first interval. And then we continue. The 5th to the 9th interval will be in the second interval. Observation, sorry. 5th to 9th observation will be in the second interval. And then we continue. The next one is the 10. The 10 up to 27, it will be in the third interval. So this 25th is actually before 27, right? So we have before 27, 26, 25, right? So the median class will be this class lah. Okay, so the class here is 165 to 169. So we can say that the median class is equal to 165 minus 169. So what is the lower boundary of 165 to 169? Okay, so the lower boundary of the 165 minus 169, we need to find the lower boundary by subtracting by 0.5. Or we just have to find the midpoint between 164 and 165. So it will be 164.5. Okay, so we just have to add up 164 and 165 and then divide by 2. So it will be 164.5. Okay, so we have the lower boundary 164.5. And then what is the next step? We have n over 2. What is n over 2? We have found already n over 2, which is 25. And then minus the cumulative before the median class. So before the median class, the cumulative will be, yes, it's 9. Right? The cumulative frequency before the median class is 9. And then what is the frequency? The frequency of the median class. Not cumulative but small f. So the frequency of median class is equal to, yes, 18. So divide by 18 and then multiply by C. So what is C? C is the class width. So how to find class width? So we learn in chapter 1, in lecture 1. So class width C is equal to the lower boundary, the upper boundary of the class minus the lower boundary of the class. So we have 169.5 minus 164.5, which is equal to 5. So multiply by 5. And then what we need to do? You just have to use your calculator lah. So 25 minus 9 is equal to 14. 14 over 18 multiplied by 5. So, and then add up with 164.5. So we have the answer 168.94 centimeter. So this is the median. Okay, so the median is equal to 168.94 centimeter. Okay, so 50% of the student will have the height lesser than 168.94 lah. Okay, so let's continue with the mode. Okay, so how to find the modes? First of all, we need to find the model class, right? So the model class, where it's located, so we need to know which one has the highest frequency. So which interval. So the model location should be here lah. Sorry, you just have to ignore this purple line. So it should be this one, 18, the highest one. So 18 is the highest one. So the model class will be 165 to 169. So now what is the lower boundary of the 165 to 169? Lower boundary will be 164.5. And then add up with the D1. What is D1? The difference between the frequency of the model class and the class before. So what is the class before? It will be the upper one. Okay, so we can see here we have 18 and 5. So what is the difference between 18 and 5? We just have to subtract, right? 18 minus 5 will be 13. And then what is D2? So D1 here we know already. How about D2? So D2 will be the difference between the model class, frequency of the model class, which is 18, and the class after. Okay, so the class after is 12. So 18 minus 12 is equal to 6. Okay, so we have the value already. And then don't forget to multiply with C, which is the class width we know already from the median, which is equal to 5. So multiply by 5. So what do we have here? All the value here, just use the calculator, you get the answer 167.92 centimeter. So the mode is 167.92 centimeter. Okay, so we are done with the mean, median, mode for the group data. Okay, so please use the formula. Please follow the same step I show you. Okay, now let's continue with the next part. Example 2. Table below show a frequency distribution of the weekly wages of the 45 employees at the P&K Company. So the wages, okay, gaji, okay. So it will be 250 up to 260. So notice here we don't have interval with the sign of this one, dash. But we have in the form of less than and less than equal. Okay? So how do we treat this type of data representation? So because we have the same value upper and lower limit here, so we don't have to worry lah. Just treat it as the lower boundary, lower and upper boundary lah. So you don't have to find the lower and upper, the difference between lower and upper limit and lower and upper boundary. Okay, so we just have to treat it as usual. So to compute the mean, median, and mode weekly wages and comment on the skewness of this distribution. So the next part is the skewness lah. So to find the mean, median, and mode, we just have to repeat the same step in the example 1. First of all, we need to do the table lah. To find the summation of fx and f, summation of f, we need the table. And then for median, the same formula. And the mode also the same formula because it's the group data, right? So first of all, we have to find what is the midpoint. So just add up the lower and upper limit and divide by 2. So we have 255 and 265 and so on. Okay, so now we have the midpoint already. So we don't have to find this part. We just have to find the summation of fx. How do we find the summation of fx? Look at the tutorial part. Okay, so directly it's equal to 12495. Your calculator will give this value lah, the summation of fx. Okay, now we just have to substitute the value only lah, 12495 divided by 45. So we don't have to show this part. you can just put 0, or you just put blank, or you can put this line. Okay, so we have the answer equal to RM277.67. Okay, now for the median, we need to find what is the cumulative. So find the cumulative first, and then the median location. So because we have the total frequency is 45, so 45 over 2 is 22.5 observation. So 22.5 observation, where is this located? So here is 1 to 3, and then 4 to 11, and then continue with 12 to 27. So 22 to 22.5 will be in between 12 to 27. So the median class is 270 to 280. So by using the formula, we need to find the lower boundary of the median class, which is because this value is the same, so we don't have to find the intermediate point. So directly we use 270. And then n over 2, we know already it's 22.5. And then subtract with the cumulative of the class before the median class. So cumulative frequency is 11. So minus 11. And divide with the frequency of the median class, which is equal to 16, and multiply with the class width. So the class width does just find the difference between the upper limit or upper boundary with the lower limit or lower boundary. Here, the same, because it's the same. But suppose the class width should be upper boundary minus the lower boundary. So it will be 10. So find using your calculator directly, we get equal to RM277.19. Okay, now the last one is the model. Is the mode. Okay, for the mode, we need to find the model class. So which one has the highest frequency, the most frequent? So it should be 16 here lah. The highest frequency is 16. So the model class is 270 to 280. Okay, now by using the formula, put the lower boundary of the model class, which is 270. And then what is the difference between the model class and the class before, which is 8 here. So 16 minus 8 is equal to 8. And then how about D2? D2 with the 10. So 16 minus 10 is equal to 6. And then the class width is the same as the median, which is equal to 10 lah. So the answer will be 275.71 RM. Okay, now we answer for the part A. How about part B? So comment on the skewness of this distribution. So we need to know what is the value of each of the mean, median, and mode. So from here, we can see that the mode is the smallest one. So if it's the smallest one, what does it mean? So we can say that mode is smaller than median, smaller than mean. Okay? If it's mode, then it will be positively skewed. Okay, so remember, we have learned it in the previous lecture 1. The distribution is positively skewed because the mean and the median is greater than the mode. Sorry, in lecture 2. Okay, so we can answer positively skewed or skewed to the positive should be to the right. Okay, so this is the comment lah. Okay, now continue. So now we want to find the variance. Find the variance and standard deviation of the following data for the mark obtained in test of 88 students. So we have the total frequency equal to 88 already. It's given in the question. And then we have the interval is the class limit is the class boundary. So it will be the same. It will be easier lah. So to find variance and standard deviation. So we need to know what is the formula first. So the formula will be 1 over n minus 1 multiplied with summation of fx square minus summation of fx all square divided by n. Okay, so for n minus 1 is done, n is done. But how about the summation of fx and summation of fx square? Okay, so we need the table. So we can show the calculation in the table as follows. First, we need to find what is x, right? The midpoint. And then we need to know what is fx. And then to get the summation of fx square, we need the x square. Okay, but we don't have to find actually the fx, the x square, the fx square for each of the class. Why? We just need the total. Okay, but what we need to put in the table is the value of x. Okay, so what is the x? The midpoint for the first class is 0 plus 10 divided by 2. It will be 5, 15, 25, 35, 45. And then if we calculate it manually, we will have the value lah. This is directly manually. So we have the total of fx and the total of fx squared. But in assignment, we can just skip this part. Why? We just need the summation of fx and summation of fx squared. We can use the calculator, the function in the calculator. Okay, so now we have already the summation of fx and summation of fx squared. So we put the value 1 over n minus 1 is 1 over 87 lah. And then multiply with summation of fx squared, which is 83800. And then minus with summation of fx and then square, we have 2510 square and then divide by n. So n is equal to 88. Okay, now we have all the value. Just put in your calculator. We have the answer for the variance is 140.321. Okay, now how about the standard deviation? So standard deviation is just the square root of the variance. So standard deviation S is equal to square root of 140.321, which is equal to 11.846. Okay, example 4. When laying pipes, engineers test the soil for resistivity. The table shows the result for 160 test. So now they want you to estimate the range. Okay, for the group data. Okay, the range for the ungrouped data, we know we just take the highest value minus the lowest value, right? But for the group data, how do we find the range? Okay, so we need to just use the upper class boundary of the highest class, which is here is equal to, the upper class boundary is equal to 20,000. And then minus the lower class boundary of the lowest class. So what is the lowest class boundary of the lowest class? So the smallest, which is equal to 400. Okay, so it will be 20,000 minus 400, which is equal to 19,600. Okay, but actually for the group data, this is not the true value lah. Why? Because these 6 data in this interval, it may not be 400, the smallest one. Right? It may be 450, 431. It can be anything. We don't know the raw data. But we use this formula lah to find the range. So this value is not exactly true talking about the range lah for group data. But for ungrouped data, it will be okay lah. For group data, it will be inquiry lah. It's not a good estimation or to explain the measure of dispersion. Okay, so example 5. Okay, so we have the data A and data B. So we need to find the mean, the standard deviation, and coefficient of variation. So why? Because mean and standard deviation will be in the formula of coefficient of variation, hence comment in the results. So to find the mean, we need what? So what is the formula of mean? What is the formula of standard deviation? Okay, so for data A, we need to find each of the data. For mean, we need the X, betul? Midpoint. So we need to find the X. And then for the standard deviation, which is the variance juga lah. So we need the summation of fx and summation of fx square. That's why we have this representation in the table lah. Fx square. X, because we need to find fx and fx square. So what is x of each of the class? So 6 plus 8 divided by 2 is 7. 9 plus 11 divided by 2 is 10. And so on. So we have the x. Now to find fx, we don't have to multiply each of these. We just have to find what is the total by using the calculator, the function inside the calculator. And then summation of fx also, we can use your calculator to find it, which is equal to find the mean, we need the summation of fx only, right? So the mean will be 202 divided by total frequency, which is equal to 16. So the answer is 12.625. Okay, so this is for mean. For the standard deviation, we need the summation of fx squared. also using the calculator. So usually in examination or in the assignment, we directly put all the value we need in the table lah. So use the calculator directly, we get the answer. So we have summation of fx equal to 202, summation of fx square equal to 2746. So standard deviation by using the formula 1 over n minus 1, so 1 over 16 minus 1, and then multiply by summation of fx square minus summation of fx square, and then divide by 16, which is n. So we have this value, s is square root, right? So square root of variance. So we have this, use the calculator, we get the answer equal to 3.612. Okay, now we found already the standard deviation. You can find the variance and then standard deviation following the step as the previous example, but you can directly use the square root of this variance formula. Okay, so now the next question is to find the coefficient of variation. So coefficient of variation is the formula of standard deviation divided by the mean. So 3.612 divided by 12.625 multiplied by 100%, we get 28.61%. So this is the coefficient of variation, CV. Okay, so this is for data A. How about data B? So data B, the same thing as we do in data A. We need to find x, we need to find fx, we need to find fx squared. So x, directly we get 10 plus 19 divided by 2 is equal to 24.5. 14.5, sorry. And then for the next one is 24.5 and so on. And then we have total frequency equal to 25 here. And then for summation of fx directly from the calculator, we get 852.5. And then to find the mean, just put the value into the formula, 852.5 divided by total frequency, which is equal to 25. So we have the answer 34.1. And then for the variance or standard deviation, we just need to continue with the value of summation of fx squared. So we have the value here, substitute all the value into the formula. So 1 over n minus 1 equal to 25 minus 1. And then at the top, it will be summation of fx squared, which is equal to 35166.25 minus summation of fx, which is equal to 852.5 square divided by 25. And then you just use your calculator, you get the answer for the standard deviation equal to 15.9. Now, for the coefficient of variation, so use the formula, which is the standard deviation 15.9 divided by the mean, which is equal to 34.1, multiplied by 100%, we get 46.63%. Okay, now we have all the value. The last question, they ask you to comment on these two distribution. So what we can do is to compare the coefficient of variation. The same as the ungrouped data. The coefficient of variation will tell you about the dispersion of the data. So which one is better, more consistent or less consistent? So we just have to compare like that. So we can see that data B has a bigger coefficient. This is bigger. 46.63 is bigger than 28.61 of the variation, and hence is much dispersed than data A. Or you can also say that data A has a smaller coefficient of variation, right? And hence is less dispersed, vice versa, dispersed than data B. You can also, okay, or kalau much dispersed, so less consistent, we also can use less consistent. But much dispersed must be put lah. We can write down much dispersed and less consistent. Okay, we cannot just directly write down the less consistent. We need to put the much dispersed. For this one, less dispersed and more Allahu Akbar. More consistent. You can put these two things lah. Much dispersed should be less than consistent. Less dispersed will be more consistent lah. Okay, so that's all for the data distribution. Okay, so settle. We have the data description. Sorry, data description. For this topic, it's really simple lah, but you need to do more calculation. You need to know how to use calculator lah. So I will tell you in the tutorial part. Okay, so you can try to explore on your own. If you try to Google or YouTube, you will see many tutorial video about the calculator in data description. Okay, so thank you class.